It is called a simultaneous equation because you need to solve equation 1 and 2 together to find the value of x and y. Okay, so there are 3 ways you can get things done. The first method is called elimination. Okay, so to do this, you need to decide which of the variables you want to get rid of. Okay, so you can decide to eliminate x or eliminate y, and from there you're able to find the value of the variable not eliminated. And then the second is the substitution. Okay, so here you need to go to either equation 1 or 2. Okay, then make x or y the subject. All right? So after doing that, then you go back to the other equation and substitute that expression and find and continue the calculation from there. All right? And the last part is the graphical method. Okay, so it requires that you use graph to get things done. So I'm going to use each of these methods to solve this same question. All right. So please keep in mind that no matter the method you're using, okay, so the result you're going to get will always be the same. All right. So let's start with the elimination. Now to do this, we need to decide if we want to eliminate x or y. All right. Now if we decide to eliminate x, then we have to make the coefficient of x to be equal. Right? And if we decide to eliminate y, then the coefficient of y should be made equal. Okay? Now this time around, we're going to start by eliminating the coefficient of x. All right? So of course, we know this is 1x. Okay? So how can you do that? You take the coefficient of x here and multiply everything there. Okay? And you take the coefficient of x here and multiply everything here. Okay? So of course, if you say 1 multiply all of this expression, I mean, nothing changes, all right? So you're still going to have 2x plus 3y equals 8, all right? Then here, 2 times x is going to be 2x, 2 times y is 2y, and 2 times 3 is going to be 6, all right? Now, at this point, the next question is, what are we going to do to eliminate x? Should we subtract or should we add? Okay, so of course, the only way is to subtract, because if we say 2x less 2x, it becomes 0. We've eliminated it, all right? And whatever you do into this expression, you have to do it to this and also that, okay? So, yeah, so if you subtract, this is gone. Then 3y less 2y, we have only 1y, okay? And 8 less 6, we have 2. So you see, we already have that the value of y is 2. Okay, now to find x, we're going to go back to either equation 1 or 2. And in the place we see y, we're going to replace it with the value 2. Okay, so we can easily do that from the second equation, right? So the second equation is x plus y equals 3, okay? And y is 2 equals 3. So x becomes 3. If the 2 crosses, it becomes a negative. So we'll have 1. So you see that the value of x is 1 and the value of y is 2. Okay? Now the next thing I'm going to do is, so instead of eliminating x, okay, I'm going to eliminate y. So the point of doing that is for you to see that we're still going to arrive at the same results. All right? Okay, now if we want to eliminate y, then the coefficients of y have to be equal, right? So here, this is 1y. We're going to use the 1 to multiply everything there. And this is 3y. So we're going to use 3 to multiply everything here. Okay? So again, 1 multiply all this, nothing changes. then 3 times x is 3x. And 3 times y is 3y. And 3 times 3 is 9. Okay, so again, to get rid of the y, we need to subtract. Okay, so if you say 3y less 3y, it becomes 0. So it is eliminated. And also, the subtraction has to apply to everything. So 2x less 3y is going to be negative x. This part is basically 0, right? Then 8 less 9, okay, we have negative 1, okay? So we can cancel out, and x becomes a 1, right? So you see that we still have x to be the same value we had when we eliminated x, all right? So now we can go back to equation 1 or 2. So anywhere we see x, we're going to replace it with the value 1, right? So let's do that from equation 2. So x plus 2 is 3. Sorry, x plus y is 3, right? And x is 1 plus y is 3. So y becomes 3 less 1, which is 2, right? So you see whether you are eliminating x or eliminating y. Okay, so the final results will always be the same. Okay, so that is what the elimination method is all about. So you have to decide which unknown that you have to get rid of first. Okay, now the next thing I'm going to do is to use the substitution method, okay, to solve the same equation. So again, we're still going to arrive at the same results. All right, so let's see. Okay, now the substitution method requires that we go to either equation 1 or equation 2, okay, and make x or y the subject. And we can easily do that from the second equation, okay? So let's make x the subject now from equation 2. So x becomes 3. The positive y crossing becomes a negative y. So I'm going to call this equation 3, okay? Now the next step will be I go to the first equation. Wherever I see x, I'm going to replace it with this expression, okay? So that is basically where the substitution comes into play, all right? So we have 2x plus 3y equals 8. So 2 multiply 3 less y plus 3y equals 8, okay? And 2 times 6. 2 times 3 is 6. 2 times y is 2y, okay? Plus 3y equals 8. So negative 2 plus a 3 will just give us a y, okay? Then the 6 crossing becomes less 6, which is a 2. So again, we have the same value of y as 2. Then to find x, we can just go to the equation 3 and replace y with the value 2, okay? So x is going to be 3 less y, which of course is 2. That gives 1. All right. So whichever method, we're consistently getting the same results. Okay, x is always 1 and y is always a 2. All right. Good. So again, if you decide to make y the subject from here, okay, you're still going to have the same results. Okay. Now the next thing I'm going to do is to use the graphical method to solve the same question. Okay, but I must tell you from the beginning that, I mean, if you really want to get something accurate, okay, you need a graph paper with scales. So because it's going to allow you to read out the correct numbers. All right, but in this case, I'm just using a board. So there, okay, but let's give it a try. So what I'm going to do now is I go to equation 1. So if x is 0, okay, then it means 2 times x is 0, right? Then y is going to be 8 divided by 3, okay? And if y is 0, then this means this part becomes 0. Then x is going to be 8 divided by 2, which is 4. So I'm done with the first equation, okay? And then I go to the second equation. If x is 0, okay, then y is basically 3. And also if y is 0, then x still becomes the same 3. Right, so yeah. Okay, good. So we have everything we need. Now we can go to the graph. Here is y and here is x. Okay, now for the first equation, x is 4 and y is 8 over 3. Okay, so I'm going to put 8 over 3 here. Okay, and then for x, which is 4, I'm going to put it here. All right, so if I join, then it means that this line is basically telling us something about the first equation. Okay, then for the second equation, x is 3 and y is also 3. All right, so 3 is going to be here. All right, let's say 3 is going to be here for x, so we join. Okay, so the second line represents everything about the second equation. All right, now at the point of intersection, which is here, if you trace down and also trace here, that's what will give you the value of x and the value of y that satisfy both equations. Okay, of course in this case I can't obviously say anything, right? All right, so x star and y star. So that's what gives you the x star and the y star that satisfy both expressions. Okay, so if you're using a graph paper with scales, then for sure you're going to see that the value of x here is 1 and the value of y here is 2. Right, so it's always important to use a graph paper to do this part. So that's it. Right, so no matter the method you're using, you will always get the same results.